Welcome to the Uptime Wind Energy Podcast. We have an excellent show ahead.
We've got a couple of stories involving wind turbine wakes and some research and modeling that's been done about, how long wakes persist from ArcVera, and also how the wind turbine wakes interact with each other, and some research on optimizing overall output of wind farms that's come out of MIT.
And then we'll discuss some work from Sandia Labs on offshore vertical axis wind turbines and the implications of that design.
And last, but certainly not least, we'll talk about what Michigan State is doing when diving into some recyclable resins and creating edible gummy bears from wind turbine blades.
It's going to be a great show. Stay tuned. We'll be back after the music. All right, wake turbulence is becoming a more frequent topic in the wind energy community, and it seems kind of obvious that when wind turbines spin around, there's probably creating wakes, but I don't think we understood how big those wakes are or how big those wakes are going to be, particularly when we get offshore and we start talking about 10, 12, 15 megawatt machines. Well, ArcVera has been looking at it, and ArcVera has done some analysis on it and predictions. Actually, more than predictions, they've actually set up a test case in Iowa. So ArcVera predictions are on offshore up to 1 meter per second drop in wind speeds due to upstream tip vortices, essentially, that are moving downstream and disturbing the airflow for the subsequent wind turbines. And that's on a big 12 megawatt machine. And that's, roughly a 10% drop in the wind speeds, which is significant. So you can see a 10% drop in output. And I know we talked about Dominion Energy on their offshore project having a capacity factor around 42%. And Rosemary and I both agreed that seems a little maybe aggressive because of things like this, the unknown unknowns. Well, ArcVera is saying, hey, these wake losses are going to be significant, and not just immediately around the wind turbine, which is creating them, but like 100 kilometers downwind, there's going to be these significant wakes. And I think that's new. Now, the piece that I haven't heard before is the testing they did in Iowa. So they validated in Iowa, and it says on the onshore validation study that ArcVera conducted in Iowa, wakes were found to travel over 40 kilometers over land in stable atmospheric conditions. Wow, that's a long ways. In American terms, that's like 25 miles, roughly. That's like the next town over. that's a lot of wake vortices. And Rosemary, you talked to Jessica O'Connor when we were down at American Clean Power in San Antonio, and as Jessica gave you some really good insights about this. You want to describe what all the knowledge she laid on you?
Yeah. So, and people can, maybe we put in the show notes if we do those. I'm not sure. We can put a link to that previous episode because that was really interesting. She explained about their model that they're doing. And so it's no surprise to anybody in the industry that there's a wake behind a wind turbine, slower and more turbulent wind behind the wind turbine than in front. We're all aware that extracting energy from the wind after all. But what was surprising about their simulation results when they applied it to offshore, they applied the simulations that they frequently do onshore, and they validated, as you said, I can't remember where it was, some American town, and found that the wake persists quite a long way. What they did was applied it to the model to an offshore site, and it's where there was that recent auction in the US around New York area, right?
Yeah,
New York, by York.
Yeah.
And they've just parceled up this bit of, I always want to say land. It's not land, but this ocean area. They've parceled it up, and there's a ton of wind farm projects that are being developed there now, and they're packed pretty close together. They've really just divided it up, like they're dividing up fields. It's not like they've left large bits of space in between them. And that research showed that the wake persists much, much, much further than what people probably expect. And I mean, obviously we don't have access to the financial models of everybody who bid in that auction, but it seems hard to believe that they would be expecting such extreme losses. And so, yeah, a 10% reduction in wind speed at a downwind wind farm, it yields more than a 10% reduction in power output, right? Because the power in wind varies with the cube of the wind speed. So it's more like
that's true,
25, nearly 30% loss. And it's not obviously, it depends on the wind direction, but there is a really a prevailing wind direction that is accounting for most of the money that the wind farm expects to make. And I mean, the results that she said, 1 meters per second was not the most extreme by any means. That might be a very common amount of reduction to see. But, there were examples where you could see, like, I think even 4 meters per second. It was incredible. Wow. So where the simulation is up to at the moment, it's validated with the onshore model. So offshore is quite different. We don't know how accurate it's going to turn out to be. But it's certainly, it's this kind of simulation can give you the bounds of what you might expect. And I think if you're a project developer, you really do want to try and find the worst realistic case that, could happen because, if you're going to consistently see 25, 30% less power than what you're expecting, I mean, I don't know many business cases that have more fat in them than that, So it could be really, really significant. And it's something for developers to be aware of. And maybe also when they are sectioning off these bits of ocean, maybe we'll need to leave some more space in between wind farms in the future.
Right. And Joel, you and I have been working on a couple of projects here looking at vortices off of blades. What comes out of the manufacturer, the tip vortices can be pretty substantial, just a clean, brand new blade.
Yeah, and so for the listeners out there that aren't 100% sure of what we're talking about, if you've ever seen a LinkedIn or a Facebook or a YouTube video of a turbine that's on fire, and you can see the smoke curling around, right? That's what we're talking about. As the wind blows through, and you can see that form behind the structure itself. Now we're talking about those things. Of course, it's not going to be a tube of just this one little vortice. It'll affect all the air around it, and if if there's a bigger array in the wind farm, you're going to affect larger weather patterns. So from those small, like Alan, like you're saying, the vortices that we see on the tips. And we look at CFD models quite regularly, and you're looking at things down to the size of your cell phone changes. So much of that in a large wind farm, especially when we're talking 100-meter blades, 100-meter plus blades. That extrapolates and becomes a lot larger. So to the one point I was thinking about while you guys were talking, now, we know that we've seen studies of the highest wind turbine. I think the wind turbine we ever saw was that one study in Germany where they're going to put them up 250 meters in the air. Most of them onshore, 80 meters, 100-meter tower height. That's all you're going to really be. Offshore, 150 or so, just to get, so the blades aren't slapping the waves. But do you think, and maybe Rosemary, this is a question for you, that these wakes, these massive amount of wakes and disturbances that these wind farms can create, could they affect weather patterns at a minute scale?
Yeah, I mean, they must, right? Because they are taking energy out of the wind. They're slowing the wind and changing it. Mm-hmm. But I think, and it is a question that comes up pretty often. It's one thing that often climate change deniers try to throw out there is, you're going to change the weather worse with wind turbines taking all the energy out of the wind. And they say it about solar panels too, which is a bit more of a stretch. We're going to take all this energy out of the sun and the wind, and we're going to affect, climate worse than fossil fuels. And I mean, definitely the scale is not remotely the same.
No.
Yeah, but I do see from time to time studies that show, effects on local weather, but it's always so it's so hard to get good controls for that kind of
for a natural phenomenon.
Kind of work. And simulations, they need to, it's like that, a butterfly flaps its wings in Australia and you get a drought in, I don't know, in China or something, whatever the typical example is. The weather's chaotic and complicated, so it's hard to simulate it. And it reminds me a bit of, like the rain shadow thing. I know that there was some cases some legal cases in the US where someone who was seeding clouds to get more rainfall on their farm was sued by the downwind farm. It's like, you've stolen my rain, and now I don't have the crop yield, and I want retribution. And it's like you can say, yes, cloud seeding has a statistical impact. Very hard to say exactly precisely where and what, and quantitatively. And I think it's the same with the wind. Yes, we know there's some energy taken out of the wind. It's going to have some effect, but we're not yet at the point where we can pinpoint and say exactly what. And it's certainly not on the scale of all the CO2 emissions in the atmosphere causing climate change.
So the last question and thought I have there is, okay, now that we're getting closer to, quantitative, you mentioned it, right? Now that we're getting closer to possibly quantitatively measuring some of this stuff, in mind of the 42% numbers that we saw with Dominion, do you see the possibility in the future, or now or in the future, of wind farm operators suing each other if they're upwind or downwind, taking production away?
Yeah, exactly. I mean, and so, that's what I immediately thought of. American wind farmers suing other American wind farmers because I know that they've done it with the cloud seeding. But I think that it would be kind of fair enough to sue if you had an offshore wind farm and then a few years later somebody got allocated one upwind of you, put in a big wind farm. And then, you would be able to document a decrease if yours was there first. I think that would be kind of fair enough, because when you committed to this project and whatever you're paying for access to that space, you did it without the knowledge that there was going to be someone upstream, upwind. But with the recent auctions, they were all done at once. So they know that these other wind farms are going to be in there. So then I would really say that's just on them if they didn't understand the issue properly. Whose fault is it but theirs? And it really seems likely that they didn't understand.
Yeah, I'm thinking about like in the North Sea right now, where you have, some of the historical, the first wind farms offshore, 6 megawatts and 5 megawatts and 8 megawatts. And then 10 years later, they get what we're looking at now, the V236 or whatever it is, that's 15 megawatts, gets thrown up in front of them. It's going to start messing up the smaller ones downstream.
Yeah,
for sure.
Definitely.
I think I think leading edge erosion is a big deal in terms of vortices. Yeah. Some of the quieting pieces we add, VGs will spin the air and probably suck a little energy out of the air more than they would otherwise. I think you could, in theory, put some requirements on what kind of vortices your wind turbine can generate, and at what point do you need to go out and fix leading edge erosion. If you think about a wind turbine blade versus an aircraft wing, there's a lot of work done on aircraft wings in the last 20 years on tip vortices and knocking them down somewhat. And I think Boeing and Airbus have done a really good job of doing that, but you don't see that translate into the wind area very little, almost not at all. But if you're talking about 100 kilometers of weight vortices and the wake you create, you'd want to try to minimize as much as you could. Would you then put in rules to force the upstream wind turbines to have vortex mitigation? I think you probably could.
Could be a great marketing strategy for one of the OEMs, right? Hey, we sold our turbines to these guys and we reduced the tip vortices. You guys should buy ours too, because then we're all going to be in line with this.
Making more money, right? Yeah, you don't want to destroy the next guy. That's not helpful, right? Because Rosemary's right. You'll be in court forever, and that's not a good place to be. But I think ArcVera is bringing really good data to this, and at least getting the discussion in place before we have a couple thousand wind turbines off the coastline and realize we have a big problem. So if you're one of those companies that are putting wind turbines off the coast of New York, you may want to talk to Jessica O'Connor or Farah and get the details of the study.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
So a new study out of MIT, and if you've been following LinkedIn news reels of the last couple of days, you'll see this article pop up a lot, and it's in the Boston Globe and a number of other periodicals. It's talking about MIT looking at essentially wake steering, the direction you take a wind farm. Each of the wind turbines, if they're operated to maximize their power individually, you'll get a certain amount of output from the farm. If you think about the turbines as part of a larger system, you may not want all your wind turbines pointing directly into the wind to maximize the output. Well, some engineers at MIT have been looking at this over in India and have run a couple of studies on it and on a decent sized wind farm. And what they're saying, Rosemary, is you can increase in certain situations power output by up to 32%, but overall it's about 1.5 to 3% in real terms from most situations. And this seems like new knowledge. I'm not sure this is really new, is it?
No, it's funny because this is a topic that pops up over and over again. And I'm always surprised at how popular it becomes, in quite mainstream media. Really similar variations on the same theme. The last one that I saw reported heaps, even more than this one, was some study that was done on vertical axis wind turbines and found that you could, put them closer together than you can horizontal axis wind turbines. And that particular study, the vertical axis wind turbine one, was, it was so preliminary. It was, two-dimensional analysis. They used 3 wind turbines. They used just a couple of different angles of wind, and it's, not validated with anything in the real world. So, I won't get too much into that one. I can say a lot about that study. But this one, it's a little bit better in that they have actually modeled a range of conditions, and they are reporting the, most common improvement. Because usually when you see these kind of results, you just hear, we'll get 32% improvement. But when you look into the details, it's like, okay, if you purposely arrange your wind turbines in the worst possible way, then you could see 32% less energy compared to the ones, arranged in the best way. So I guess the first place to start with responding to this is that wind farm developers do already consider the effect of the other turbines in the wind farm when they're locating them, right? We all know that wind turbines extract energy from the wind, and the energy in wind is it's kinetic energy, which means they're not like consuming air molecules. So the only way to remove energy from the wind is to remove wind speed. It's it's half mv squared, right? The kinetic energy. So you got to take some of that v out. And we all have known since the start of modern wind turbines over 100 years ago that's how wind turbines work. And so therefore necessarily behind a wind turbine there is lower wind speed. So every time this is reported, it's always like, oh my God, wind turbines, it's been found in this breakthrough study that wind turbines remove energy from the wind. Who knew? And it's always like a little bit offensive because like, how dumb do you think that this whole industry of wind energy engineers are, that it hadn't occurred to us that wind speeds are lower behind wind turbines? So that out of the way, and bearing in mind that we already don't just line them up directly, in a row with the wind turbines in the direction of the wind. Yeah. That said, wake steering, which is what I usually call this effect of, you don't consider the control of each turbine individually. So, the normal way to operate a wind farm is that each wind turbine has a controller. It knows what its wind speed is and how it should operate to get the most energy that it can. And so the ones in depending on where the wind direction is, the front row of wind turbines will be different. But, the front row wind turbines are probably doing something different to what the back row wind turbines are, because they're seeing different wind speeds, different turbulence and that sort of thing. But the new thing with wake steering is that you don't optimize every individual turbine's output. You optimize the output of the whole wind farm as a whole. And so you can, if you do have some wind turbines, considering the current wind direction, if you have got some that are really seeing the wake of the turbine in front, if there happen to be a few of them lined up downwind, then you can tilt the front one a little bit so it's not getting the maximum energy it can, because you tilt it slightly out of the wind, but then its wake moves away from the turbine behind it. So the turbine behind will get more energy. And if you do that cleverly, then you can end up with more energy from the wind farm as a whole. And so this article is saying that's in normal conditions a few percent, which is in line with what I've heard before. So I think it's exciting because it's a way to get more out of an existing asset without having to install, like new wind turbines or change the blades or anything like that. But it's not easy, and we're not seeing, this idea has been around for, I'd say, around 10 years or so. And you don't see a huge take up of it because it's complicated and it affects, the wind turbine structure. Right. It's not designed for these weird kind of off-axis operation. Is it really certified? Are you really going to get the lifetime? OEMs aren't so keen to mess around with that.
Right. And Joel, at Wind Power Lab, you guys deal with broken blades all the time and fatigue issues and the manufacturing variations that come out of the OEMs. It seems like if I'm not going to point my turbine directly into the wind, and they're talking about in some cases up to 20 degrees of orientation away from the wind, it seems like you're putting a lot of extra, maybe flexing loads, bending loads, fatigue loads onto my blades. When does that come into play versus the extra power you may generate?
I would say that if you see someone doing this commercially, I would almost guarantee you they're out of their OEM warranty period. That's the first thing I would think. Because I don't believe, and I could be wrong, any OEM, feel free to contact us and let us know, but I don't believe that any OEM is going to say, yeah, do that, you should be fine. In some of the things we've read is, up to 20 degrees out of the wind. I mean, think that the structural loads that are placed on the blades and the bearings of, pitch bearings and the yaw bearings, everything that's just, it's just not quite, they're not designed to do that, right? So I would say, first off, they're probably out of their warranty. Right. Second, if I was an insurance company, I would be looking into that as far as putting some more bullet points in my policies, because I wouldn't want to be on the hook for someone changing things up and possibly folding a blade over or messing up a bearing. Like you guys know, a hub bearing goes, that's you're not going to get that for the same price of a cup of coffee, right? So no. I would say there's some things, tipping, I would think tipping 1% and 2% and stuff. And maybe there's some studies out there. I know, like we were talking about earlier, Windesco does this commercially. They have their swarm technology and whatnot. I would be curious to hear from them as far as if you're moving 1%, have they done studies? Has a certification body looked at this and said, yeah, it looks good to us, or what is the max that we can start moving things around? Because you go outside of the OEM's shut off wind speeds, and then you got to idle them anyways and try to make them not be affected by wind. And it's the same concept.
Well, Joel and I have worked with a company that does yaw alignment, and so there's a big emphasis on actually making sure your turbine is pointed the way it's supposed to be. Checking to reduce vibration is a big deal. Yeah, it makes the turbine live longer. So there are a couple of companies, the one we know in particular is based up in Canada, but they're out running around checking yaw alignment all the time, and you'll say, "Oh man, some of these turbines are crazy out of alignment." So if most companies are already out of yaw alignment and it's damaging components, and that's the story that I hear very consistently, doing it on purpose doesn't seem like the right way to go unless you have some assurances from the OEM that it's going to work. Because, the other part about this, which is a little upsetting, is there's a company called Windesco, which is based in Massachusetts and not very far from us. And they are a stone's throw from MIT. They've been working on this problem for several years. And I think they have a better handle on what can and can't be done. But yet you don't read the news article about those guys. Windesco is out there doing it. MIT is talking about it, in some sense, sort of talking about it and self-promoting, which is fine. But there's already players in that space that are already probably 5 years out in front of what MIT just did. Not to say what MIT is wrong. It's good to have more data, but it does seem a little bit odd that MIT didn't mention Windesco.
Yeah,
down the road, literally.
Speaking of, the experience that we have with some of the groups out there doing alignments, I know that in some of the reports that I've seen from them as well, the increase in energy output that they're trying to gain from the wake steering adjustments here, 1%, 2%, 3%. Sometimes those guys are seeing that 1.1%, 2%, 3% increase in power output just by getting them aligned perfectly, because in the vibrations, they're losing that, right? So if it was my wind farm, I would rather say, guys, let's go and align them perfectly and get that extra 1% or 2% rather than let's throw them out of alignment and see if we can do the same thing.
The academic research, it has a place, and this MIT research, it's validated with a real wind farm. So that's, a big step up from most of the studies of this kind that I see. My problem is almost never with the research. And if you read the paper itself, they're not, their title of their paper won't be 30% improvement over, idiotically designed normal wind farm. It'll be very nuanced and accurate, and probably it may well even reference all this other work. It's the reporting that's a problem. And it's a real challenge to get, report engineering in a way that people can get excited about without being misleading. It's, it's a challenge that I have with my channel, and maybe why my channel is, 1/10 the size of some of the more sensational ones. But, I think that it's not the research that's a problem. And I also wanted to point out, I did a live stream on all different ways of grouping wind turbines a way back. Maybe it was earlier this year. I'm just looking at the date. It was, November 2021. And there was one really cool resource that I included in the description to that, which I'll send to include in the show notes here. But there's this DTU simulation called Top Farm. It's a Python code, but you can run it. I'm not, real computer programming type. I'm a bit of a hack, but even I managed to install it. And you can run your own wind farm optimization, and you can choose what parameters that are important, and you're trying to improve the financials of the wind farm overall. So that includes trying to get more power out of it, but also trying to minimize the cost of power lines that need to connect these things up and that sort of thing. So I thought that was really cool. If people think it sounds really exciting, it's nice to be able to go and play around and see what kinds of what kind of changes you can make that make a difference, and also evidence that this is something that we knew about in the industry before this latest article, if you don't believe me.
I would like to shout out to the person who signed the contract at Dominion for 42% uptime. And when they get near their trailing 3-year average and they're at 41, call Windesco and have them crank it up 1% just for that year so you don't get burned. Keep that in your back pocket. You're welcome.
And a separate shout out to Lars and Yannick Benson with AC883. They're the guys that we have talked to about yaw alignment, and they're doing it quite a bit. Those are two good guys, and they're out hustling and making the wind turbines perform a lot better. So it's shout out to those guys. If you're interested in yaw alignment, just go to ac883.com and you can find out a lot more about it.
Get the latest on wind industry news, business, and technology sent straight to you every week. Sign up for the Uptime Tech newsletter at weatherguardwind.com/news.
All right, so the folks at Sandia have been working on a vertical wind turbine, and in particular, a vertical wind turbine that is floating offshore. So they've come up with this concept. In fact, they patent this design, and we'll put it in the show notes. But it's essentially, it looks like a bow from a bow and arrow. So you got this kind of curved blade, and there's a cable that reaches the top of the blade and pulls it down. So you get this bow-like structure with this blade, and that cable ties down sort of to the base. And so now you have a vertical axis wind turbine, and you have 3 of these things, and you can adjust the tension on those cables, pulling those blades to essentially stabilize the thing. And they've been working on software to control this vertical axis wind turbine with this unique blade system. And they got the software because they're trying to figure out how to handle the waves and the turbulence and all the things going to be thrown at a floating platform. So even though it'd be anchored down to the seafloor, it's still going to be bobbing and moving and tilting and stuff. I guess my first question is this design something that would theoretically be used? Because it's all right now is in theory. I've never seen a production one of these. I'm looking for some. I was looking online for some. In like a blade sample or something, a test that's been going on. I haven't really seen anything, but Sandia seems to be progressing down this line. Is this something that we really need? Is a vertical axis wind turbine that sort of floats offshore?
Maybe. So vertical axis wind turbines, they're not new at all. And in the 70s, 80s, early 90s, there wasn't really a industry agreement that horizontal axis was the only way to go. There was plenty of serious research effort, serious development money spent on vertical axis wind turbines. And the most successful and biggest of those looked a lot like this one. The egg beater shape is what it's commonly known as. It's got there's some advantages to vertical axis wind turbines and some disadvantages relative to horizontal axis. And for onshore applications, it kind of just worked out that the downsides to the vertical axis wind turbines were so much more than the advantages. And so it kind of died out. Evolution killed that. But now we've got new constraints, new design requirements for offshore that do make it seem attractive again. So there are a lot of companies that are looking at vertical axis wind turbines for offshore and especially floating offshore. One of the main things is that the center of gravity is much lower because you can put the generator at the bottom of the turbine. And so, I don't know if how many people
big advantage
this show versus listen to it, but I've got a little wind turbine here, a horizontal axis one, and I mean it just looks wrong that would float, right? Like it looks like it just wants to tip over. Whereas with the I don't have a model of a vertical axis one, but it looks like an egg beater, and the mass is all down the bottom. I should have planned ahead and brought a whisk with me. Yes. For the show and tell session today. But yeah, so you put the generator at the bottom, which makes it, just inherently more stable. You need a smaller floating platform to keep it upright. That's the number one biggest thing. There's a few other differences, but I'd say that's the biggest. So Joel's going, yeah, it looks like that, like a lolly. Why do you have that? What is that?
I don't even know. A kid set it up. One of my nieces set it on my desk.
Well, it's kind of like that.
Yeah,
if you're watching on YouTube, it just looks just like that.
Yeah. So I mean, there is a reason to go that way. As we really want to get more floating wind out there, if we're going to be able to expand offshore wind to areas beyond, the good offshore sites are already filling up, shallow waters that are suitable for the fixed bottom offshore. So floating offshore is something that probably does need to happen, or at least it will really help the energy transition if we can install a lot. And so It does make sense. To me, it does make sense to reopen vertical axis wind turbines now. And this Sandia design, it's taken the most successful one from the 90s. There's a really huge one if you drive from Montreal to the LM wind power factory in Gaspé on the Gaspé Peninsula in Canada, then you'll drive past, I think it's called Cap de Chat, or Chat, the Cape of the Cat, I guess. And there's the world's biggest vertical axis wind turbine is still there. It's unoperational, but it's this just huge, big egg beater. But one of the big challenges with that design was that you've got this big cantilever structure, right? You got a vertical,
right.
A vertical tower, the generators at the bottom, blades at the top, and the bearings are at the bottom, trying to keep this whole structure aligned, and
stable.
That was really challenging. And the way that they solved that onshore was nearly always to put guy wires, so they would attach to the top these guy wires that would come out the side like a tent, but that's really a lot harder to achieve offshore because you don't just have land to peg the corners down to. So you would need to make your floating platform, big enough to take those guy wires to, and then you eliminate the whole point of that you could have a smaller floating structure. So this is a way of getting around that, solving the same problem in an offshore appropriate way. That's my interpretation. And then some of the other stuff, the other reasons why vertical axis wind turbines didn't succeed and kind of died out in the 90s was because of the aerodynamic loads change. On a horizontal axis wind turbine, it's very simple. They're the same all the way around, and it's really like an airplane wing. Whereas with a vertical axis wind turbine, the wind direction is constantly changing relative to the blade. So they're seeing, they get dynamic stall. It's making lift, and then all of a sudden it stalls, and it's huge sudden change in drag. Also, the materials at the time, they were using aluminium mostly, not great in fatigue, which is not great for constantly, if you've got constantly changing loads, you've got, severe fatigue impacts. So some of those have gone away with materials. Composite materials are much better for fatigue, and we've got much better simulation tools for complicated structures like that and complex loading. And then the controls as well. If you can control on the millisecond kind of level, then you can reduce some of that dynamic loading. So, all of those things. Things are very different now. We're trying to do something different, and we've got much different tools now than we did in the 90s. So I think that's why we're seeing quite a lot of people pretty interested in vertical axis, especially for floating offshore wind.
Yeah, but we've created this new Rosemary rule of maturity. The Rosemary rule of maturity is everything takes at least 10 years, maybe 20. So if Sandia hasn't built one of these yet, no one has. How far out would a vertical axis wind turbine be?
There's a company, C12. They have a very small prototype that they I don't have the actual size on hand, but they have actually made something and stuck it in the ocean, and it generated power. But I'm pretty sure it was kilowatts, not and not hundreds of kilowatts.
Okay. Not megawatts. Okay.
Yeah, definitely not megawatts. There might be one or two others. There's plenty of people that will sell you a vertical axis wind turbine to put in the ocean. I am super skeptical that those will do what they say, because I believe that we would have seen evidence of it if they did.
Well, that's just it, Rosemary. Because it didn't take off the time when it needed to take off. Is it too late? And our efforts like Sandia, and there's a lot of brilliant people working at Sandia, obviously. And they have to think 20 years out in the future. That's their role. But is it sort of too late to go back and do vertical axis? Because we just don't, in the United States, we don't even have the infrastructure to make horizontal wind turbines right at the moment, let alone do something unique and vertical.
Here's a chance to get in.
Out?
No, I see it as quite a classic disruptive technology model. I don't see that there's enough of a difference right now that a major manufacturer would have any reason to get into this. Right. It's worse technology. It's got smaller markets, more expensive. Why would they be interested in, the odd, really offshore application where you could install something like this and have someone pay for it?
Right.
Someone that recognizes that has enough value from it that it's worth paying a lot extra than, compared to a horizontal axis fixed bottom turbine. But I do see that if you extrapolate 10, 20 years out into the future, I do see that if it is possible to get floating offshore wind cheap, that there will be so much of it. And so I think that this is the example. People are always asking me what's the next big thing in wind, and until recently is always like, well, wind's mature, they know how to make it cheap. Everything onshore that I see as new designs that pop up as an alternative to the just standard 3-bladed upwind rotor, it never makes any sense to me onshore. It's there's just no, the benefits aren't there. But offshore, there's a chance. I'm not saying definitely this is going to be the future, but it is the first time where I've been like, yeah, there are some legitimate reasons to have a look into this. And vertical axis isn't the only way to solve some of these problems. I'm also interested in multi-rotors. Sure. And, maybe there's others that I haven't thought of. But I do think that going offshore, like far offshore, has changed the design constraints enough that we could expect that a different design could end up being, better suited than what we've got now. So, I think it's worth pursuing. I wouldn't bet my house deposit on it, but I might bet a little bit.
What?
If I was going to bet on the future, people say bet your house, but I don't have a house. I have a house deposit, so that's all I can bet.
Well, if SpaceX can land rockets vertically and reuse them, I'm sure we can figure out how to do vertical axis wind turbines. And it's sort of, you're right about that analogy of it's just the software's better, the control systems are better, we have a lot more tools, we have better technology, we have better composites than we did 5 years ago even. The landscape is open. Joel, I think if anywhere that's going to be used in the U.S., it's going to be sort of in the Louisiana, Gulf of Mexico, Texas area where hurricanes and things can be really devastating, but vertical axis probably has a little bit of an advantage in terms of just being a little more durable. And I don't know if you saw that recent article, I think it's this week, where the BOEM, Bureau of Energy Management, I think that's right.
Ocean Energy Management or something?
Oh, yeah, Bureau of Ocean Energy Management, right? Sorry about that. That they were talking to Louisiana and Texas about offshore wind, and they've got some parcels set off in federal waters. Texas had a lot of response to that, like questioning about the birds and the habitat. Louisiana's like, nah, whatever. They didn't care. I thought, you know why? Well, you know why they don't care? One of the reasons why they couldn't care is maybe they're not going to put turbines in federal waters because Louisiana is a place where they've actually put duties or a percentage of the income generated by wind turbines offshore would come to the state. And if you put them in federal waters, the feds get to take that money. And I think Louisiana's thinking, well, we're going to keep it in a little more shallower waters. And we're going to do something that's a little more reasonable for Louisiana. And the state of Louisiana is going to keep all the proceeds from that development, where Texas probably hasn't thought of that or is not going to do that. So in this situation where you have a really, really unique environmental constraint, Gulf of Mexico, wind's a little bit lower, get this hurricane thing once in a while, maybe some of those vertical wind turbines make sense.
Yeah, I think there's definitely a possibility. I mean, of course, if they're off the coast of Louisiana, they go from floaters to fixed bottom, right? Because it's shallow, the whole coast.
Right, they would. They totally would, yeah.
But just I'm looking at this design, and it basically is, like a bottom, like tension cables, turning the blades into basically bowstrings, right? Or a bow, and then tension cables, right? So if a hurricane was to come, you release the tension on them, and then they become neutral. And I think that's right. There's something there, and I think there's a couple of advantages, that we haven't spoke about with this. Just looking again, I'm looking at the simple picture here. There's no pitch bearings. There's no pitch drive systems. There's no yaw bearing. I mean, there's technically one big yaw bearing, but technically that's the hub bearing, right? So the structure itself, component wise, is a little bit simpler. Now, the blade structure in composites and, the dynamic loads, like Rosemary was talking about, when the wind comes through, everything changes. And you get weird stall and some other things. That's a bit more complex, not a bit more. It's a lot more complex than a standard blade is. And understanding what the life of these would be based on standard operation. And then also getting into if you're going to put them into an area where there is hurricanes or some deeper offshore wilder weather. I don't know how they'll last, but I think it's definitely worth investigating.
Well, it's up to people like it's up to people like Rosemary who are designing the blade structure to get it right, and it's sort of like 50-50.
Don't mess it up.
I think it's too new. If I was designing an airplane to do that, I would think, oh man, my structures guys are really good. And if I had a Rosemary on my airplane team, I think, but it's hard. I know how difficult those things are, right? So even if you got the best people on it, it's still a really, really difficult thing to do. I've watched airplanes break in half and tested they weren't supposed to break in half, and those sort of things. Like, oh man, we missed X, right? It gets super complicated.
Yeah, you need a really good reason. You need a really good reason why you would bother. And I mean, what you said, Joel, about the simplicity of the components that can be removed, that is the motivation for at least dozens of vertical axis wind turbine companies that have come and gone over the last 20 years. And none of them have actually been able to make something cheaper than a horizontal axis one. So, that's one of the things with vertical axis wind turbines. It's a technology where if you think about it for like 1 minute, it's just so obvious that these are better. And if you think about it for 5 minutes, it's like, oh, wait, but, if you try and get that improvement, then you're going to make this thing harder. And if you think about it for 10 minutes, you're like, oh, yeah, actually, no, I don't think I'll do that. So I think it's been pretty well documented onshore that I won't say that every avenue has turned out to be a dead end. And there is one company, Agile Wind Power, who have a 750 megawatt vertical axis wind turbine prototype. And their idea is that they're going to control 750 kilowatt. nearly a megawatt.
750 megawatt. That's big.
Thanks for pulling me up. Yeah, nearly a megawatt. So, usually you talk megawatt scale and I'm always adding them in because it's not quite a megawatt, but at least it's in the ballpark. And their innovation is that they're using it's the controls. So they're going to change adjust the angle of attack of the blades to get rid of this dynamic stall problem. And I mean they've had teething problems. They're a startup, but I wouldn't totally eliminate that as a viable option, and maybe they will eventually pivot to floating offshore, because I still don't see a huge market for that. And even when you talk to them, they don't say, oh, we're going to take over all of these sites that are currently being developed with horizontal axis wind turbines. We'll have our vertical axis one in the future. They're saying this is for places where a horizontal axis turbine doesn't make sense because, of noise or because of, access problems or turbulence or something. So, it's a technology to watch, but I think if vertical axis wind turbines are going to do something big and exciting, it'll be in floating offshore in 15, 20 years. There you go. There's my time frame.
The one place that I have seen vertical axis wind turbines in public working is just outside of the Denver airport. And they have these vertical axis wind turbines that are about the size of, I don't know, maybe they're not that big. They're only about the size of a stop sign or something, but they have them installed on the median. And they have the blades that are kind of like this, right? And they're utilizing, of course, the front range of Colorado is windy anyway, so there's always some wind there. Right. But one of the reasons that's cool that they're there, if you guys have ever stood on the side of an interstate highway, when cars go by, blow your hat right off. Well, the traffic is going like this. And so the turbines are in the middle of the median on the barrier wall spinning with the traffic wind as well. So, they're probably enough power being generated there to make a cup of coffee. But
and are they collecting it's a cool that power? Concept. Or are they just spinning the toys? No, they're connected to something?
They're collecting. I don't know what they're powering with. Yeah, they're connected to something, but I don't know what. But then again, if you know anything about DIA Airport, there might be some aliens living underneath it, or
Well, that's what I was saying.
yeah.
It's a way for Colorado to slow down the drivers. They're actually taking energy from the cars and slowing it down. Somebody's thinking that. I guarantee there's a website devoted to that.
Yes. Yes.
Yeah, come on.
Because that's another common idea that people have is, we should put wind turbines everywhere by roads, and then someone will respond, oh, you idiot, that means it's just coming from the car, which... Yeah, I think it's anyway. We shouldn't get into that. It's not so straightforward to me how you would go about analyzing that one way or the other. But yeah, anyway, let's move on.
Hey, it's better than people in West Texas thinking that it's hot because the fans are turned off. No offense, West Texas. I love you guys.
I love West Texas, but I have seen that same comment. Yeah.
Yeah.
So Michigan State has been hard at work, at least a couple of the professors there, and they've developed this technology, which is using a combination of glass fiber, or I guess you could just use carbon fiber too, and some synthetic and plant-based polymers. So they're Rosemary, as you well know, they're creating these long polymer chains where you get strength from, but they're using some plant-based, some synthetic, and then they put in fiberglass or carbon fiber into this thing to create these composite structures. Now, some marketing person was genius here. He said, well, it's recyclable, right? You can break these polymers down into their independent, smaller chains and reuse them, which is great, right? It's a recyclable, quote unquote, resin system. And you can pull the fiber out of them too. So you could, in theory, reuse them. Well, one of the professors, I assumed, it's John Dorgan, chemical engineer, Michigan State, said, well, you can create this circular economy from these polymers because you can break them down and reuse them in infinitum. They can just be used all the time. Well, what can you make this plant-based polymer into? Well, you can make it into gummy bears. You can make it to food-grade quality stuff. And so essentially it goes like this. I make a wind turbine, I have this wind turbine blade. Eventually, after 20 years, I need to recycle it. I break it down to its independent components. I put the synthetic stuff in a barrel. I take the fiberglass out and put it over here. And then I take the remaining part of it and make it into candy. Make it into gummy bears. So online, you see these gummy bear images. And I got to say, guys, who is eating things that have been on a wind turbine? It indicates like the people responsible have never been around wind turbines to see how dirty they are. Rosemary, would you like to describe what typically happens to a wind turbine over its lifetime?
Well, I mean, it's not so dissimilar to if you buy a new plastic piece of garden furniture and, maybe you'd be happy to lick it when you first got it home. But after it's been in your garden for a year or two, are you still happy to lick that? I don't think so. I don't want to eat a gummy bear that was recycled from a wind turbine, and I don't really see why it's necessary either. And I also don't agree that that's a circular economy because I don't know how they're retrieving that after its second life as a gummy bear through your digestive system, but I don't want any part of that.
Well, gummy bears are not digested. I think that's what they're saying. It's just passing through
at least
temporarily.
These ones.
Those would totally be right. It could be infinitum.
And is there
we were talking
is that a
timelines
legitimate
earlier.
use for it then? I mean, you could also just shred a normal wind turbine blade and eat that. It's inert. Is that recycling?
Evidently. No.
Yeah.
Do not do that. No. Never listen to what engineers have to say about eating things, right? We're not the right group.
There's one of those Guinness record type chasers who I think he ate an entire aeroplane. Isn't that a thing that's happened? There's some guy that just eats random stuff. And yeah, if you chop, it's not going to, you chop something inert up and eat it, then it's not going to do you any harm. I guess I should put the disclaimer that I'm not telling you to go out and just, eat non-food items, but I can't see why you couldn't make fiberglass pellets out of a recycled wind turbine blade and eat them. And, I think that would be very similar to making gummy bears out of a recycled wind turbine blade and eating them. I don't see the difference. That's my point. But don't do it at home.
I think you'll see them. You'll see them in the next few years. They will be at a trade show, and they'll have packages of these gummy bears, and they'll be handing them out. Here, try this wind turbine blade. Try this wind turbine blade.
This should right. There should be a rule. If you make a food product out of recycled material, you got to make it in the shape of what it was, just so I know what I'm biting into.
This was a wind turbine.
You know what I'm saying? I think
then it should be right. Go look at your vehicle. Yeah, go look at your vehicle after a springtime ride through the mountains by your house, Alan, and see all the bugs on the front. That's exactly what the leading edge of a wind turbine blade looks like. So maybe that's what they should make them in the shape of bugs.
Understanding, Gummy bears existed before, they became some sort of chemical concoction, right? Sugar and gelatin and some sort of fruit flavoring will give you a gummy bear if you get the ratios right. So, there's some organics there. Maybe it's the bugs is where that nutritional content comes from. Maybe it's there you go. It's a feature, not a bug.
Gummy bears now with protein, protein fortified. Yeah, I'm always excited about recyclable resins. I think it's a cool idea, right? I think if you can make a plant-based recyclable resin system, there is a huge advantage to that, and I'm all for it. I guess it's just in the marketing of it. It makes it sound silly because I think this is where recycled composite parts are going to go in the next couple of years, not in Rosemary's, age of maturity for wind energy stuff. It's not 20 years out. It is probably 3-4 years out. Siemens Gamesa is always flying blades that are recyclable right now. That's happening. So the more types of resins we can see, the different kinds of chemistries involved, we're going to hone it in on something that's really good and really recyclable. And I think we'll take one of the major complaints about wind turbines off of the table. It's the blade recycling, bearing of blades falling, all those things that comes off the table as a discussion point. It makes wind energy a lot more palatable for a lot of the economies, especially in the United States, to swallow. Yeah, well, sorry. I threw it in there. I didn't know if anybody would notice. But yeah. That's going to do it for this week's Uptime Wind Energy Podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. And be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And also subscribe to Rosemary's YouTube channel, Engineering with Rosie, where you see all kinds of fabulous renewable energy projects discussed with worldwide experts. We will see you, though, next week on the Uptime Wind Energy Podcast.